Hello, welcome to Beyond Science. Today we're going to be talking about the size and mass of atoms. By the end of this video, you'll be able to recall the size of atoms, recall the charge and mass of the subatomic particles, determine the number of subatomic particles in an atom of a given element, explain what an isotope is, and be able to calculate relative atomic mass. Let's start by saying that all substances are made of atoms. A single drop of water contains 5 quintillion atoms. That's 5 times 10 to the power 18. Each atom has a radius of approximately 0.1 nanometers. That's 1 times 10 to the power minus 10 meters. Most of the mass of an atom is concentrated within the nucleus. The radius of the nucleus is only 1 over 10,000th of the total radius of the atom. To put this into context, if an atom with a width of an Olympic swimming pool, 50 meters, the nucleus at its centre would be roughly the size of a pea. Atoms contain 3 types of subatomic particle: protons, neutrons, and electrons. Protons are found inside the nucleus of the atom. They have a positive charge and have a relative mass of 1. Neutrons are also found in the nucleus of an atom. They have no charge, they are neutral, and they have a relative mass of 1. Electrons orbit around the nucleus in shells or energy levels. Electrons have a negative charge. Since an electron is approximately 2,000 times smaller than a proton or neutron, we say that the mass of an electron is negligible. In other words, electrons are so small they barely contribute towards the overall mass of an atom. An atom has no overall charge. This is because an atom contains an equal number of positively charged protons and negatively charged electrons. For example, this lithium atom contains 3 protons in the nucleus, so it also contains 3 electrons in its energy shells. The number of protons in the nucleus of an atom is known as the atomic number. The atomic number of each element is shown on the periodic table. All atoms of a particular element have the same number of protons in their nucleus. For example, all carbon atoms have 6 protons, hence the atomic number of carbon is 6. Because protons and neutrons both have a relative mass of 1, adding the number of protons and neutrons within the nucleus of an atom together gives us the relative mass of that atom. The atomic mass of each element is also shown in the periodic table. We can use the information from the periodic table to determine the number of protons, neutrons and electrons in any given element. Let's look at fluorine. The atomic number of fluorine is 9. This tells us that a fluorine atom has 9 protons in its nucleus. A fluorine atom must therefore also have 9 electrons. The atomic mass of fluorine is 19. Since the atomic mass is the sum of the number of protons and neutrons, we can calculate the number of neutrons in a fluorine atom by subtracting the number of protons from the atomic mass. 19 take away 9 equals 10. How many protons, neutrons and electrons are there in an atom of potassium? An atom of potassium has 19 protons and therefore also has 19 electrons. The number of neutrons is 39, take away 19 equals 20. Atoms of the same element can have different numbers of neutrons. Atoms of an element that have the same number of protons and electrons but a different number of neutrons are called isotopes. Chlorine-35 atoms contain 17 protons, 17 electrons and 18 neutrons. But chlorine-37 atoms contain 17 protons, 17 electrons and 20 neutrons. Chlorine has 2 isotopes. If you look for the relative atomic mass of an element on the periodic table, it isn't always a whole number. This is because relative atomic mass of an element is an average value that takes into account the abundance of each isotope of that element. 75% of all chlorine atoms are chlorine-35 isotope, and 25% of all chlorine atoms are the chlorine-37 isotope. To calculate the relative atomic mass of chlorine, we use the formula, as on screen. So 75 times 35 plus 25 times 37 divided by 100 equals 35.5. The relative atomic mass of chlorine is 35.5.